Greetings and welcome, friends. This is Mr. Waddy. We're going over last night's quest. We were talking about using congruent triangles, and these were situations in which I wanted to find out a particular relationship regarding angles or sides of a triangle, but I didn't have the means to come to that conclusion just yet. And it turns out that even though they didn't ask us to prove these triangles congruent, that if I could prove them congruent, then using the fact that corresponding parts of congruent triangles are congruent, I could then say other statements about the triangles. So, here we go. So for this first question, question 7, right, we're kind of jumping right into this. They want me to make a claim about segment GK, all right, which is this entire length, and say that it's congruent to JH or HJ. So that's what they want. I don't have the means to do that. However, if I'm looking at those two triangles, can I prove that the two overlapping triangles are congruent right now? Let's see, might be kind of hard to see those. Let's see, so here's one triangle. So in order to prove triangles congruent, I need 3 pieces of information, specific information regarding angles and sides. Does anyone see a relationship? Yeah, Josh? Right, angle, side corresponds to an angle, side. Notice the side was one of the non-included sides of those triangles. So I could say that triangle, let's say J and H, they didn't need us to go this far, is congruent to triangle, let's see, J and H, so that's going to be KLG. And the reason is angle, side. All right, so there's my reason. Now that I know those triangles are congruent, I could prove that GK is congruent to HJ. And why is that? Corresponding parts of congruent triangles are congruent. All right, so I only need 3 pieces of information to prove triangles congruent. Some combinations won't work, like angle, side, or angle. But once I prove 2 triangles congruent, I can then make 3 more I can prove the rest of their corresponding parts are congruent. Let's see, question 8. I think this one's actually not that bad. These are, just overlapping for almost no reason at all, it seems. But I think I have enough to prove these triangles are congruent. So I'm going to say triangle TRV is congruent to who now? Let's see. So there's 6 ways to name that triangle, but now that I've committed to one name, there's only one way that I can name its buddy. So WVQ, right? So the single arced angle, I had to start at the single arced vertex, so W, and then I went to kind of the obtuse one, so yeah, going to the obtuse one next, and then Q. Actually, I just realized, both of those were single arc. This was this isosceles? Were these isosceles triangles? It looks like those were all 4 angles are single arcs, right? So according to the base angles converse, I actually could have concluded that these were isosceles triangles. We didn't need to know that, but we could have, right? If the base angle, if 2 angles in a triangle are congruent, then the sides opposite them are going to be congruent. That was the base angles converse. Question, comment, Aiden? No? All right. But that was completely unnecessary. We didn't need that. So these triangles are congruent by angle, side. And now that I have that, does that help me make this statement? So let's see, QW is the long side, congruent to Vermont, represent. Let's see, so QDubs congruent to VT. Why is that, friends? CPCTC, right? Corresponding parts of congruent triangles are congruent. Wonderful, wonderful. All right, so this one, I like this. This just says, write a plan for the proof. We'll just kind of summarize this a little bit. Here's question 10. So prove that angle 1 is congruent to angle 2. Now, there are, I don't know, probably like 6 different triangles in this sketch, but the ones that I can prove are congruent, because right now I don't have a way of making a relationship between those, but the ones I can prove are congruent are these skinny obtuse ones. Right? Do you guys agree? Do you think I can prove those skinny obtuse triangles congruent? Let's see, we'll call that triangle ABE. Might as well make a name of it if we can. And triangle Abe is going to be congruent to whom? DCE? Did I have enough information to prove that? What congruence theorem allows me to?
Angle, side.
Angle, angle, side. Man, that's been showing up in all my examples so far. Because the side is not an included side. It wasn't adjacent to touching both of those angles. So angle, angle, side. Now, how is that going to help me prove angle 1 is congruent to 2? What pieces of information related to these triangles would help me move in that direction? Anyone have any thoughts? Yeah, Josh? Okay, so I might be able to work with this angle here. I actually see a few different ways of doing this. Okay, so you could work with, let's divert into 2 parallel dimensions here. So you might have said that angle Abe is congruent to angle DCE. Is that what you're suggesting? Is that where you're moving? Yeah. All right, that's true because of CP/CTC. And then I could say that angle 1 and angle Abe are supplementary. Does anyone know why that's true? What types of angles, what are those forming? That's a linear pair, so the linear pair postulate, LPP. And that is also true for angle 2 and angle DCE. And I believe I can say that, let's see, yeah, angle 1 is congruent to angle 2. This one's a much more obscure theorem. I believe it was the congruent supplements theorem. 2 angles that are supplementary to the same angle, or 2 congruent angles, will be congruent to each other. That sound familiar? Right? Think about this. If these 2 values were the same, let's say they're 120, there is only one number that adds to 120 that equals 180. Right? So whether I'm calling it angle 1 or angle 2, I know that there's only one number, one angle measure that I could add to that angle's measure that will equal 180. It's not like there's multiple ways that could work. All right, so that's one way you could do it. Another way, if I diverted, I was actually looking at these ones. I could say that these 2 are congruent to each other. BE, so this is alternative universe right here, and CE are congruent by CP/CTC. And I believe I can immediately go to angle 1 is congruent to angle 2. Anyone know why? Base angles theorem. Well done. Well done. All right, so mathematicians, when we come up with solutions to problems, we like them to be accurate. First of all, it's nice to be right. That would be a helpful solution if it's actually correct. But it's also valuable if we can end up getting something that's efficient or even elegant. So that in this case, this one's a little bit quicker for me to work with, but either of those would be full credit on a test, right? So sometimes there's multiple paths. And so this is an isosceles triangle, therefore its base angles are congruent. Wow, I'm just scribbling all over this. There we go, that's good enough. All right, last question. This one, whew, man, look at this. This is like a bow tie or something. Wow. All right, let's see what we've got to work with here. All right, lots of things going on here. All right, so I'm trying to prove PUX is congruent to QSY. All right, we good so far? We seeing that? All right, so those are the 2 big triangles I'm trying to work with. In order to do so, using like an angle addition postulate, it looks like I could say that and that. But I'm gonna need, I'm gonna need some more information here. Right? I'm gonna need another angle and another side in order to make this work out. Now, Josh, do you have some ideas?
RP.
RP?
RP.
R. V. Okay, all right. All right, I was like, I thought you said B, and I'm like, I'm not even seeing one. So you're actually saying this entire length is congruent to itself. Which triangle shares that side, though?
You could do R use and R U. Oh, you could say R U is congruent to yes.
RU is congruent to VS. I could do that with a little bit of work. Let me ask the question, where is that going? Like, where are we going with that? Are you guys trying to prove something about like these top half triangles? Is that where you're thinking? All right, I should start using multiple colors here because that's not helping. Okay, so if we make the decision, I'm going to prove something about these top half triangles. All right. If we can prove those congruent, what angle or side related to those top half triangles are shared with their grande bow tie triangles? What angle or sides do those have in common with the big triangle, Isaiah? Well, for this purple triangle, it only has half of angle U. It looks like PU is a side that is shared with the big triangle. It looks like angle P is an angle that's shared with the big triangle. So if I could prove this triangle is congruent to its counterpart over here, then I would be able to prove using CP/CTC angle P and angle Q, and I'd be able to prove that PU is congruent to QS, which that would be two pieces of information helping me with those bigger triangles. So let's, now that we've decided that, because I realize there's a lot of moving parts in this proof, how could I prove these two triangles are congruent? I currently know an angle and an angle, angle and an angle. I need a side. So I'm going to write in purple for my proof regarding the purple triangles. All right, so I would have just whatever my given information is. We won't relabel that and take that time just right now. Right, all of the labeled given information. I've got angle, angle. I need a side somewhere. This is not the side of a triangle. That's a part of a side. But if I knew RU, that would be helpful. Well, the labeled congruence only applies to this length, which is part of like a quadrilateral, but it's not related to the entire side of a triangle. But I think, yeah, my ceiling is vibrating. I think if we could prove RU congruent to SV, that would be helpful, and I'd have an angle side angle at play. In order to show this length, what is that length made up of?
RS.
RS and SU, and SU, notice, is in both of those segments. I think if we say SU is congruent to itself, actually I'll just say us. Yeah, that sounds nice. Why is that? Why is it congruent to itself? Reflexive property, right? Part of the challenge of this proof is just like seeing kind of the forest through the trees here. There's a lot at play. I believe there's some segment addition postulate that would be helpful. How would that help us out? What two statements could I make using segment addition postulate? Thoughts? Isaiah?
RS.
Oh wow. Okay, so you're actually already like applying a transitivity. I was going to say RS plus SU equals RU. All right. So I'm referring to this entire side is equal to the sum of its non-overlapping parts. Right? And then a similar statement. I'm working in the direction that you are, Isaiah. So you're definitely thinking the right thing. And then I think I could say that UV. Oh, that's a terrible V. There we go. That's a little better. Plus us is equal to who? UV plus us VS or SV. And that's segment addition postulate. Okay. Now, let's see, do I have enough to do some transitivity or substitution? I want to end up with saying RU is equal to SV. Now I've got, these are congruent to each other. In one of my given statements, I already had that RS was congruent to UV. And so I think I can combine, let's see, I could take RS and substitute it in right here. You guys agree? You guys seeing that? So according to substitution, I could say let's see, RS, sorry. And I'll just switch these letters around. Is equal to VS by substitution, prop of equality, technically. And now that I have that, let's see if you guys can see what's at play here. I'm going to say that RU is equal to VS because this statement and this statement are the same. All right, so if RU is equal to the orange statement and the orange statement is equal to VS, then they are equal to each other. Why? Transitive or substitution in this case. Either of those do work. All right, so that's trans or subs. And then RU is congruent to VS by the classic, what reason? Def of Cong. Here we go. All right. So we've come a long way. What has that helped us do? Now I can prove two purple triangles congruent. That was a lot of work just for like proving two segments. So I'm going to say triangle PRU is congruent to triangle, let's see, PRU, so QVS. And what reason did we claim? I think one of us named it like 5 minutes ago. Angle, side, angle. So I've got angle, I've got their included side, and an angle, yeah. And now I'm going to start working towards my big triangles. All right. So because of that, I believe I can say that PU is congruent to QS. Why is that true? Corresponding parts of congruent triangles are congruent. All right, so let's see. I'm up to a 3 tick mark, aren't I? 1, 2, 3, and 1, 2, 3. And I try to aim like my tick marks kind of at the midpoint of the entire segment. I'm trying to minimize misinterpreting that tick mark as representing just PT and not the entire PU. What's another fact that I've got? Josh?
PX is congruent to PY.
Let's see, PX? I don't think I have that yet.
Can't prove the whole thing.
Right now, all I've got are two sides for the two yellow triangles.
That PR.
PR is congruent. Yeah, I could prove that, but I don't yet know where these lengths are with relation to one another. How about angles? Any angles from the purple triangles that overlap with the yellow triangles? I asked that question also like 5 minutes ago. This is just a long problem. Isaiah? Let's see. S and U? I'll get there eventually. I've got to use angle addition postulate to make it happen. Let's see. How about this? Who's angle P congruent to? Are those angles also in the purple triangle? Yes. All right. So by CPCTC, those angles are congruent to one another. Now, all I've got is angle and a side right now. Is there a way that I could prove this angle and this angle are congruent?
What about angle R?
Yeah, angle R isn't an angle that is one of the main 3 angles of the yellow triangle, though.
Oh, yeah.
Right, so it doesn't, like, there will be information about those purple triangles that are true, but they won't all necessarily be helpful.
So like you're trying to fit the angle.
Yeah, there's a bunch of angles there, but I think I know which ones you're talking about. Okay, so let's see, last setup. So I'm going to say angle TSW, or measure of angle, sorry, is equal to the measure of angle TSU plus the measure of angle WSU. So I'm saying the big angle is equal to the sum of the two little angles. Why is that true? Similar to this. Except I'm talking about angles here, so it's angle addition postulate. This proof is crazy long. This was like the boss fight of the proofs we've done so far.
Even the end of the book.
Yeah, I know. This is crazy, but you guys are getting good. All right. Similar statement, different reason, or sorry, same reason, different statement, my bad. TUS. What is the, sorry, TUW, my bad. What angles is that equal to for TUW? TUS. All right, we're committed now. And WUS for the same reason, angle addition postulate. All right, so I've got those big angles here. I'm going to need some substitution at play. Let's see. So all of those angles are congruent to each other is a statement that would have been in my givens. All right, I had this little angle, this little angle, this little angle, this little angle. So using def of Cong, I could say that all of their measures are equal. All right, so I could have said, I might not take the time to write it down so we can get into today's lesson. But by def of Cong, I would have said the measure of angle TSU is equal to the measure of angle WSU is equal to the measure of angle TUS is equal to the measure of WUS. All right, all of these angles were equal to each other by def of Cong, or their measures were all equal because we already knew they were all congruent. And then by substitution, yeah, this is a lot of work. But we are so going to know this is true by the end of this. By substitution, I'm just going to replace this with this. The measure of angle TUS plus the measure of angle WUS. All right. If this is true, right, I basically can rearrange this using all of these individual statements, right? You guys agree? You don't even know?
Simplify this or
No, like this is just a crazy long proof, isn't it? That's why I was trying to like at least color coordinate it for us. All right, so if all of these measures are equal, well, let me show you the substitution. Let's see if we can follow it. So let's see, TSU, let me show you the statement I'm going for. By substitution, I just replaced TUS with TSU. So if TSU is equal to TUS, I was able to combine those in this statement up here, right? If those two things are equal, then I can substitute. Similarly, if WSU is now being replaced by WUS, I could take WUS and plug it in there because their measures were equal. Substitution happened. Whew. Guys, we're almost there. All right, let's finish it off. We're losing energy on this. Measure of angle TSW is going to equal the measure of angle TUW. By transitive or substitution, right? Because this is the same as that, and this is equal to the orange statement, and the orange statement is equal to that. They must equal each other. by transitive property or subs. All right, do I have, let's see, which angles are TSW and TUW? Let's go back to our sketch real quick. So TSW and TUW, I'm talking about the grande angles here, and I'm not going to put 5 arcs, I'll just label them orange. All right, those are the angles I'm working with. If their measures are equal, how do I know they're congruent? If the measures are equal, how do I know angles are congruent? We're almost there. Def of Cong, all right? I realize there's a lot going on here, but maybe I'm hoping you're at least catching 90% of the individual components, okay? Def of Cong. And I believe we have enough to say our triangles are congruent, which is what we set out to prove, 20 minutes ago? All right, PUX, QSY. And for our yellow triangles, if I have got this, side, angle, what way do I have to prove those triangles are congruent? Angle, side, angle. So look at just the PUX triangle. Angle, side, angle. Whew. Wow, this problem was a beast. Done. All right, so hopefully you guys have stopped crying moments ago. All right, let's get into today's lesson. Have a great day, internet friends.